Hello, everybody. Welcome back to the last section of Chapter 1 about composition of matter from Purposeful Design Physical Science. Today, in this last section, Section 4, we're going to be talking about suspensions and colloids. Our objectives today are to compare heterogeneous mixtures. Remember, previously we talked about the fact that there are two types of mixtures. There are homogeneous mixtures and heterogeneous mixtures. So today we're focusing in only on heterogeneous mixtures. And we're going to talk about and be able to explain something called the Tyndall effect. So the first type of heterogeneous mixture we're going to talk about is a suspension. This is a mixture in which the particles of a substance are mixed throughout but are large enough to settle. So an example of this would be the muddy water in the background of this slide. That once that water is not moving so quickly, when it's calmer, the particles of sand and clay and all of that will settle out to the bottom and the water on top will be clear. So if this was not moving as quickly, it would settle. In a suspension, two things we need to know are that the particles are large enough to see and can be filtered. Another example of a suspension is Italian dressing that you have to shake up to mix it up, because you know that the water and the oil, or the vinegar and the oil, will separate into different layers, and also all of the herbs will settle to the bottom, so that needs to be shaken because it is a suspension. Also, suspensions block light. You know that muddy water, you cannot see through it. So they block light. Another type of heterogeneous mixture is a colloid. And this is a mixture in which the particles of a substance are dispersed throughout and are not large enough to settle. So these will not settle out. The particles are too small to see and cannot be filtered. And an example of this is milk. In milk, you can't see through it, but you can't see the particles that make up the milk either. And so that is an example of a colloid. With these mixtures, we will see something called the Tyndall effect. This is the scattering of light by colloids. This provides indirect evidence that a mixture is a colloid, not a homogeneous mixture. Sometimes we don't know whether it's a colloid or it's what we call a solution if it's a homogeneous mixture. For example, you are drinking a glass of lemonade and you want to know if it is a solution, which is a homogeneous mixture, or a colloid. So what we do is we shine a flashlight through it. If the light goes through without any cloudiness, look to it, then it is a solution. It is a homogeneous mixture, and you should see that normally with a glass of lemonade. If it is a colloid, it will appear foggy and cloudy, and so that tells us that it is a colloid. This will happen if you put even just a couple of drops of milk in a glass of water, because milk is a colloid. It will scatter that light. So the light scattering is that cloudiness that we see. And so a good example is fog. Fog is a colloid of air and water. This is why when you're in a car and it is foggy, the headlights, if you put them even higher to try to see better, it makes it worse. You cannot see as far with high beams on. You have to put your low beams on, or if you have fog lights, you put those on, which directs the light more towards the road, because adding light scatters that light all over the place and you cannot see. That is why the clouds up in the sky also look white. It's due to the Tyndall effect. So we will be using this in lab actually to take a look at different liquid mixtures to determine if they're homogeneous mixtures or colloids. So this was a fast one today. Our objectives were to compare heterogeneous mixtures. We took a look at two different types, suspensions and colloids, and the big difference was that in a suspension, the particles will settle out. In a colloid, they will not. And we also talked about the Tyndall effect, the fact that if we shine a light into a liquid mixture that looks relatively clear, and we can determine whether it is in fact a homogeneous mixture because the light will go right through without any cloudiness, or whether it is a colloid where the colloid, due to the Tyndall effect, will scatter the light and it will appear cloudy. The light will not go directly through. So if you're my students, go ahead right now and write your 5 questions in the margins and start studying for that test. Prepare for your test. Use your questions to review and study for the Chapter 1 test. And if you're also in my class, be ready to do a lab on determining whether a liquid mixture is a homogeneous mixture, a solution, or a colloid.